All right, welcome to chapter 17, which is calculating KSP from molar solubility. Remember, KSP is the equilibrium constant, and SP stands for solubility product, and these are for salts that are not very soluble, meaning they only ionize slightly. Okay, so not very soluble salts. And because they're not very soluble, we're going to break them down to equilibrium as opposed to what we used to do, which was just a one-way arrow, because we assumed most salts were all strong electrolytes and 100% ionized. So the hint that they are not very soluble salts is if they give you a KSP value, it's most likely a not very soluble salt. So identify the major species in this one. So silver, sulfide. Okay, this is a salt. Metal, non-metal. Remember, for the sake of this class, anything that's ionic is a salt. Metal, non-metal, +1, -2. So we're going to write out the reaction now. This is just a salt in solution. Okay, and it's at equilibrium because it's not a very soluble salt, because it's a KSP problem with its ions. So we have the silver ion and the sulfide ion. All right, and we're going to set up the equilibrium expression, and now we're going to call this KSP equals products. So silver ion raised to the second power, and the sulfide ion. Okay, now remember, ions are always aqueous. Okay, and our salt is going to be considered solid at room temperature. Okay, so it's just products over nothing because we don't include solids in the equilibrium expression. So we just have our ions in this equilibrium expression. So if our job is to calculate KSP, we must have enough info to plug and chug into here, and we do. I gave you mass of the salt in volume, so this is old school stuff. We're going to find the molarity. So you're going to turn grams into moles using molar mass, and let me take a second to look that up. Okay, so it looks like it's 247.8 or something like that grams for every 1 mole. All right, that gives you moles, which looks like it comes out to be 0.0019 something moles per 0.250 liters, and that gives us the molarity of the salt, which is 0.02077 molar silver sulfide. All right, so we're just going to plug in. Now be careful. So KSP is going to equal, remember that you have double the silver ion, so you have to take this number for silver and multiply it by 2, because every time this salt breaks down, it breaks down into 2 of the silvers. Okay, and then the sulfide is just 1 of the ions. Okay, and don't forget to square this, because our equilibrium expression, there's a 2 out front. So there should be a 2 up here as my exponent, and just solve for KSP. KSP ends up equaling 1.8 times 10 to the -6. Now, remember, this is a small K value. So what does that mean? That means if we have a really small K value, it means we have a lot of reactant at equilibrium and not a lot of product. So a lot of reactant means you have your solid state of the salt, not very soluble with small K values. And that is how you solve a KSP for a salt that is not very soluble.